This conference will now be recorded.
Okay, so good morning team. In this Databricks Data Engineer Master Program. So in today's session, we will talk about Delta Lake Architecture Internal Working Mechanism Part 2 with the deletion vector. So yesterday we have discussed without deletion vector. Today we will talk about deletion vector. But remember, due to the time constraint, yesterday we just discussed 65 to 70% of the concepts hands-on. So that's why what I will do is today there won't be any theoretical session now. So slides, whatever we discuss, the same will be there. Deletion vector also I discussed yesterday, right? So deletion vector means instead of rewriting the data into the new file, it will mark the records as deleted. What is the advantage of it? On huge data, rewriting will be like rewriting will hit the performance. That's why we want to avoid rewriting the data, and we need to mark the records, or if the record is updated, we just want to mark the record is updated. Okay, so that is what the difference between the deletion vector and without deletion vector. Without deletion vector means records will be rewritten every time into the new file when you update, delete and everything. If you enable the deletion vector, the records will be marked as a deleted within the same file instead of rewriting, which improves the performance. So today, directly I'll just jump into the hands-on. But remember one thing you need to note down: deletion vector supports Databricks runtime 14.3 or above. What is the version? Everybody tell me which version it supports.
14.13.
14.3 and above. Okay, by default deletion vector will be enabled for 14.3 and above. If you want to disable, you can able to disable, but if you want to enable, you can able to enable anything you can able to do. So we will see how you can enable, how you can able to disable the deletion vector. By default, what I am currently using is I have created two workspaces today. Okay, here I will explain to you without deletion vector. Yesterday we have seen, but we completed only half. That's why I want to continue with this. I'll complete this lab. After that, immediately I switch to the, so you see here 48 is there. This is in the one account. This is under cloudpandit@outlook.com. So this is cloudpandit@gmail.com. Okay, this account is totally different. So you will come to know why I created two accounts and all. I'll tell you. Okay, I'll tell you the reason for creation of the two accounts, but I'm going with the outlook.com here without deletion vector. Okay, this is without deletion vector. Without deletion vector means what happens, Tim? Tell me. Now tell me.
If
Without deletion vector means what happens?
record is deleted, so that time
Not only when the record is deleted, when the record is updated, in all cases we have
inside,
seen.
yes, yes.
Yeah. Now let me just go to the Azure. Let me create one Azure account because we are trying out all these things on the external tables, right? Manage table is very easy to explain, but as you requested me to explain with external table, I'm just explaining with the. So resource group, let me create dev hyphen RG. Click OK. Data lake name cloud pandit dev ADLS. Click next. Enable hierarchical namespace. Click review plus create. So it is created. What are the next step, team? What is the next step? Go to app registration.
Registration.
Go to this user. This user I'll be adding in the data lake storage. Already if you look at same user, application ID, same ID, 2BDF F2 F9 last. You can see here 2BDF F2 F9 at the last. So same application, same app registration username, password, directory ID. I kept it here. Okay. Now dev ADLS I created. This is a storage account. Now only thing that we need to do is for this particular storage account, containers, access control IAM, add role SNA. We need to add this user with the which role team? Storage blob data contributor.
Storage blob.
Select members. This user you can give here. Click select. Now what happens? This user is having permission to access ADLS. That's why I'm creating one container also global. Okay. Now if you come here, so this is the data lake. Within that global container I created. This data lake is having permissions. This data lake we can able to access it using this username and password, because this user is added into this data lake storage with this cloud fund, with the Azure uh, data contributor access we have granted. Azure storage blob data contributor access we have given. Storage blob data contributor access. Clear all of you team? So with this, first now what I'm doing, I'll attach this cluster to this notebook. And the very important point to be noted here is that runtime that we are using. Currently I'm using the runtime is 12.2. You can see here. Okay. Because here there won't be any deletion vector, so that's why I'm explaining to you here version number 12.2. Now first let me unmount the storage account. Okay, create a mount point again. Okay, first of all let me clear all cell outputs. Okay, now I am disabling auto optimizations that will takes place. Optimize write means while writing the data, it will optimize where it has to write and all. Auto compact means if you have a small files, it will combine into a large files. All those things I am disabling to see what exactly happening. Okay, so tell me this path is available currently in the data lake or not. We mounted global, but we haven't created anything. If you list down, it will fail. Correct?
Yes.
What is this table team? Is it external table or is it a managed table we are trying to create?
External
External will be creating
external
in this
table.
location. Let's create. So create table schema using type is delta, location is this is the location in which we are creating the delta external table. How we will know whether it is external table or internal table? How we can able to know that? Do you know how we can
Mention the
verify?
location path.
Huh?
Location showing MNT. If it is managed table, then it will store in high place.
No, I am asking through the commands how you can verify. Is it a managed table? Type of table I want to verify. Not
Describe.
just by look. Huh?
Describe formatted. Format describe.
Very good. Describe extended or formatted EMP table. If you give what it it will give complete information. Type of table is external. In which location it is available here. All these things we discussed. Fine. Now, after creating table, let's see whether this particular path existed. Yes. You can verify these things here also. Only thing is it is time waste if we go every time into the here and look at this. See, everything will be there here, but I am opening those things here. Okay, see under emp underscore delta log is there. Underscore delta log, what we have inside this, we have one Cyclic redundancy check, it is nothing but a checksum file. It is mainly used for the internal purpose, for the data integrity purpose. JSON file which has all the information what is happening. But yesterday we have seen, again today I'll show you, but just a bit. After few minutes, like in few seconds, we'll open it. What I'm doing here,
Adding constraint.
okay, we are adding the constraints. Let's
Constraint.
add two constraints. Now tell me total how many transactions we completed as of now?
3.
Total 3.
3 transaction means how many dot JSON dot CRCs will be there?
2.
Huh?
3.
3.
3
Okay.
JSON.
3 JSON, 3 CRC will be there. Okay. Let's verify this table. What columns? Yes, these are the columns that we have. Describe extended EMP to know what is the type of table and all. And you can see the configurations, the table properties and all. Okay. Next. Describe detailed EMP. You can able to see everything in a single line. So this is the path created, when it is created, when it is last modified, everything will be there. Now I am listing down the here what is there under EMP table. It is having only logs because we have not inserted any data. That's why still only logs are available. Now inside logs, what exactly it is there? If you see, this is a one transaction log, this second transaction log, this is a third transaction log. This is for some optimization it is added, but in the future when we enable deletion vector and all, you will not be able to see because those things will is not going to generate in the future versions. Okay, those are some optimization technique files, so those we no need to worry about it. Only thing is here, this is a transaction 1 file, transaction 2 file, this is a transaction 3 file. Now let's open the first file, right, this is how you can able to read the content, which makes very easy for reading the content. Okay, first commit info. When commit will happen, whenever particular transaction is successful, then only commit is going to happen. As the first transaction is successful, commit happened. What is this commit all about? Create a table. Okay, create table. Create a table is the first transaction what you have done. When you created a table, okay, you can see, right, you just created the table. Is a manager table? False, because it's an external table, that's why it's a false. So all other things will be there. This is commit info. Next, metadata. We will come back to the metadata. Second row is protocol. So when you create a table, by default table properties, read version 1, write version 2 it is using. These are the Delta Lake versions that it is using to read the data. It is basically using version 1 Delta Lake. For writing the data, basically min writer version 2 it is going to use. Default properties are added. Okay, we already discussed all about this. Quickly I'm discussing now. Now if you see, this is a metadata where you have information, fields, id, name, age, active, data types, nullable. All these are nullable, true. But in the second transaction we made id column as a not null. That's why let's look at the second transaction. Commit info, second transaction is successful. What is this second transaction? Is change column. What is the column? id, type is integer, nullable equal to false. This is what we have changed it. Same will be updated in the metadata. You can see here nullable equal to false. Okay, now third transaction. What is the third transaction, team? It is for the adding the constraints. Add constraint. This is the constraint, team. Whenever you add a constraint, write version 2 won't work. That's why it upgrade the delta write version to 3. Okay, it is upgraded. All these things we discussed, team. If anybody is not aware, let me know. Okay, so now if you come here, metadata will not change here, but this constraint is added as part of the configurations. You can see auto optimize dot optimize right is false, auto optimize dot auto compact is false, because at the very beginning we made these two as a false. Along with that, now we added a configurations, that is a constraint called check constraint. That constraint also we can able to see here. Now this is all about the JSON file. You know, CRC file also will have almost similar content, but it will have more of internal related things. Okay, so I'm querying, go to focus mode. You can see here all files. Okay, histogram opt, this and metadata you have here. Okay, all the columns and all. Number of files, there is no data added, that's why number of files is 0. Number of metadata is 1. Number of protocols are 1. Protocols, these are the protocols. Table size, transaction ID, set transaction. So this is all about the first one. Now first transaction. Now I am moving on to the second transaction. It has the same metadata will get updated here also, you can see. So null will equal to false. Metadata updated. Number of files is 0. Still we have not added any data. So all these things will be there as this. Now this is the third transaction CSV file. So, sorry, CRC file. It has the same. You can see check constraint is added in the metadata. Num files is 0. Metadata files. All these things are going to be same type. Only thing is here min writer version will change. Okay. Now what we need to understand now is come down, describe history EMPT. See, there are three things, three transactions. These are the three transactions what we have done: create table, change column, add constraints. Now we are trying to understand Delta Lake is efficient and in handling data using statistics. Let's understand how it will maintain stats when we insert one record versus multiple records. Okay, now I am inserting a one record. When you insert one record, what will happen? This is a fourth transaction. When the fourth transaction happened, it is going to create one. So this is the insert, right? You are adding a data, means what happens? Parquet file will be added, which
Parquet file is created.
okay. Now let's go inside underscore delta log. Okay, this is the underscore delta log. See here, fourth transaction log is added. Let's understand what is there in this. Here itself you can see. So it is saying number of records are 1. Minimum value is 1 Rama is 32. Maximum value is also 1 Rama 32, because it's a single record. That's why it is the add. Add means file is what type? File is added. File is added. But before you add, there is one more row is there. So commit info. Whenever transaction is succeeded, it will commit. What is this commit? Write operation. How many files are added? Number of files are added is 1. Number of output rows are added is 1. What is that one row? You can see in the file. This is a file which is added, and in this file number of records are 1. This is the minimum record, this is the maximum record. Now what we need to do? Yesterday we have done. Now tell me what we need to do now. We need to take what we need to take. Tell me. Parquet file. Keep this. Remember, in this file we have a record number 1, ID 1 we have. Okay. Next, come down. Now I am inserting a second row. Now tell me, this transaction is successful or failed?
Fail.
When transaction is
Fail.
failed, now transaction log, will it add or not?
Not at it.
No. But Parquet file, will it add? Yes. Parquet file will be added, but it's a corrupted file. That's it. You can say earlier it is a B7. This is the file which has the one. Now this is the file which is added, which is a corrupted file. Okay, you can say this is this Parquet file, you can say corrupted file. Okay, next. If you
So
come
for
down,
this file, JSON and CRC file won't create, right?
won't create.
Inside.
I
Yeah.
am showing you that. You can see a 03, which is a last transaction when the success commit happened. That is nothing but when we insert a first record. You can see a commit info is right. Okay, you can see what is that record exactly. This is a num record 1, minimum ID 1 rama is 32, maximum also 1 rama 32, because this transaction is failed, this transaction log is not added. That's why the latest JSON, the latest transaction log, when you read, it is showing the previous log details. Okay, previous success commit log it is showing. Clear team? Clear? You can see, right? 1 rama is 32. In the CRC also you can see same record. Now even if you history, if you describe, you can able to see only one write operation when we inserted 1 rama 32. 2 Krishna, when you inserted, it got failed. That's why that write operation details are not captured in the history or in the transaction log. But history also comes from the transaction log. Till here clear?
Yes.
We discussed all these things yesterday. I'm just repeating because I don't want to give keep you any confusion. Okay. Now we are inserting multiple records. When we inserted multiple record, do you think it creates a multiple Parquet files or it will create a single Parquet file?
Single Parquet.
Single Parquet.
Parquet file. Yesterday we've seen, right? Now let's see. What is that Parquet file which is created? I think this is a 40. 40 is nothing but a this, and this is a newly added file. What data we have in this file now? Tell me. 4
Yeah.
records.
4
2,
records.
3, 4, 5. Correct? Now same we can also see through the log. So this is the 4th log. Okay. Now let's read this log.
So I have one question. The Parquet files is generating, right? It will store. It will save on with this timestamp.
Yes, it will have a timestamp. Yes.
Okay.
So this is a success transaction. That's why commit info it says write operation. Number of files added is 1, but number of rows added is 4. If you come here in this file, it says number of records added is 4, minimum record is 2, maximum record is ID 5. Clear? Everybody is clear, team? Yes.
Yes.
With the CRC also you can able to see similar kind of thing, but it is not keeping 2, 3, 4, 5. Instead it is just putting stats. What is the minimum? What is the maximum? Okay. Now let's update the data. Select star from EMP. So when I read this file, can you tell me how many files it is going to read? Will it read these 3 files or will it read only 2 files?
Only two files.
Only 2
Two
files.
files.
See that? See here number of files read is 2. Why only 2? Because first record you have here, 4 records you have here, which makes the 5 records. Those are the total records of the EMB table. So the second file is corrupted. It is not going to scan that. Okay, remember that. Now let's say I am updating this record. when I update this record, this is a new transaction, isn't it? What will happen when I update the record? Let's see. So now you can see whether update the record is available or not. Yes, 5 new Venkat is there, but now let's see, is there any fourth Parquet file is added or it's not added? Let's see. Is it added fourth Parquet file? That is nothing but this is the file which it is added, 256. So, but we don't know what data we have in this file, right? Let's understand that through the transaction log. Now, so transaction log is added, 5.json. You know how many zeros we have? 20 zeros will be there. Okay, 20 zeros. If you put like this, it is a 20 zeros. Last number will be added, meaning that much transaction log you can maintain it. That's why they are maintaining the transaction log file name is very big name. Okay, now you updated the record. What happened? Let's understand. Commit info update. Okay, in the update you see carefully, it says lot of information. Number of added files are 1 file is added. Number of removed files is 1 file is removed. Number of copied records is 3, meaning 3 records are as it is copied into the new file. Number of update records are 1 record is updated. Now let me clear this. Let me tell you, you have a earlier 1 file which has a 2, 3, okay, 4 and 5 records we have. Now what happened? You did a update on this. Now what happened? It is created a new transaction. It copied 2, 3, 4, 3 records. It copied into the new file as it is, and fifth record is updated and copied into the new file. So that's why updated rows are 1, copied rows are 3, total 4 records, and this file is added, this file is deleted. This file is deleted means this file will be marked as a deleted. Marked as a deleted means this file, it says now this file is no longer required. What is this file? What is that file? Let me show you. What is the file which got removed? You can see that here, where you can see this is the place where you can see the removed file. Let's go to the focus mode to see clearly. See commit info, I have shown you. Just now I read the commit info. Okay, now I am going to the remove. Here, what is the file which got removed? You can see E0. E0 is removed. Let's see. E0 is nothing but this one. This is now removed. Removed means it will be there, because removed means it will be there, but when you read it, instead of this, it is going to read this. In this, 2, 3, 4 are 2, 3, 4 are copied, 5 is updated and loaded into the this new file. Okay, clear all of you? Everybody understood? How you will know it is added into this file? You can see that file name here. Num records are 4, 2 is the ID, minimum value, name new Venkat is the minimum value, age is 22 is the minimum values in this particular file. Maximum values are ID is maximum ID is 5, Srini is the maximum name, age is 55 is the maximum age column. Maximum age is 55 is there, minimum age is 22, minimum name is new Venkat, maximum name is Srinu, minimum ID is 2, maximum ID is 5. So this is all the stats. 4 records are added into this 256. Parquet file name is 256. In this it is added. Now we can validate. Is it correct or not? How we can validate? Yesterday we have seen that, right? So CRC I'm not showing. CRC it is not having that much information. Now Delta Lake is smart enough to read or scan only relevant files which has latest updates data and skip irrelevant file scan. We can also see number of files read through Spark UI. Now if you see, it is reading this data. Now in order to read all this data, how many files it has to scan? How many files it has to scan? Tell me.
Two files.
It has to scan this file and this file. Let's see that. Two files scanned or not? Let's see. Here you see job ID 7071. Click on this. Come down. You can see number of files read is how many? 2. Clear? Select star from EMP. How many files it will read?
One file.
Only one file. You can see here. Number of files read is only one. Now, if I say select star from EMP where ID in 2, 3, 4, 5. How many how many files it will read now?
One.
Only one, because 2, 3, 4, 5 is available in only one file. So that's why it is going to read only one file. Number of files read is 1. Next, if I say select star from ID here 1, 2. When I say 1, 2, how many files it will read now?
Two files.
Huh?
Two files.
How many files?
Two files.
2 files. Because 1 is there in a separate file, 2 is there in a separate file. That's why number of files read is 2. Okay. Now select star from EMP where ID equal to 10. It is not going to scan because through the logs it understand. So ID is not exist. So that's why it is not going to read anything. Okay. Till here we covered yesterday. Now let's say delete from EMP where name equal to new Venkat. I deleted. When I deleted, what will happen? Let's see. So this is a new transaction. So is it added a fifth file or not? Let's see. E0B742 532. I think this is a file which got added. But what it is doing with this file? Let's understand that. Okay. This is a new file added, but we don't know what data is there in this file. Now let's understand through the logs. So what is the latest transaction? Latest transaction is 6. We need to put here 6. Go to focus mode. It is easy for us to understand. So now commit info, successful transaction. That's why commit info is added, deleted. Okay. Number of copied rows are how many? 3. Number of deleted rows are 1. Number of added files are 1. Number of removed files are 1. Meaning here what happened? Here we have 2, 3, 4, 5 is available in one file. So now what happened? As we deleted one record, okay, total 4 records are there, out of which one record is deleted. So now these 3 records are copied into this file. This file is added and copied these 3 records, and this file is removed, and this record also removed from this file. Understood, team? Now let's see what is the file which got removed, what is the file which got added. So you can see this is the file 256 is something which is removed. This is removed. And now what is copied here? So new file is added 532. Let's see whether is it 532 only added or is there anything else is added. You see 532 is added. In the 532 number of records are how many are there? 3. 2 is the minimum, maximum ID is 4. Meaning you have in this only 2, 3 and 4 only available. Now in the table, tell me if I query the table, what records it has. This record and this record only. All these are removed in the current version. So that's why this record and this record only will come. 1, 2, 3, 4 should come when we query it. Are you able to understand this?
Yes.
Yes.
Okay. Now you can also see through the describe history EMP. See, deletion happen. Now you can also see select star from EMP. It will give you 1, 2, 3, 4 records only. See, it is not giving any other records. Can we go back and get the deleted record? Yes, we can revert back the transaction. That's where time travel versioning will come into the picture, that we will discuss in the next session. Okay, are we good? That's why these files are not removing. Why we are not removing these files? These files still have this data. Tomorrow if you want to go back to the previous version, you can go back. Understood?
Yes, ma'am.
Okay.
That's why those we are not dealing. Okay, so this is the employee table. What we have, team 1, 2, 3, 4 I have. Now fifth record I am adding, and the third record I am updating. 3 Sai 33 and active equal to, I am marking it as a false. He is an inactive employee, and there is a Shashi employee is added. So there are 2 records. Now this is the new table. Consider as a source table. This is a target table. Okay, so this is because already managed table I have created while testing. You know, right, where managed tables will be available? You know or you don't know?
Yes. Yes. Slash
Yes.
user highway.
Now let's create and insert the data into this table. Now this is the new table that we created, 3, 5, and this is a target table. What we have, 1, 2, 3, 4. Now if you see, third record is updated, fifth record is new record in this. Now how to upset? Merge functionality is nothing but upset. Okay, merge into EMP. I want to add this new data which is coming into the target. That's why merge into the target table. Which records you want to merge into a target table? Using the source records. So from source some new records are coming. But how you want to merge? First I'm checking whether target table ID and source table ID is matching. If ID is matched, means when matched, if it is matched, then do one thing. If ID is matching, means it's a existing data. So that's why you update the name, you update the age, you update the active. Meaning one of the data, maybe name, age or active might be changed. That's why can you update all these columns into the target table? I'm saying, let's see if the ID is not available, what it means, it's a new record I want to insert. That's why when not matched, then insert. So these are the 4 columns. These 4 columns data I am getting from the new table. See, from the EMP update dot ID, EMP dot update dot name. So this fifth record I'll be inserting, because that will not match. Fifth record I'll insert, third record I'll be updating. That's it. Understood, team? Everybody understood here?
Yes, sir.
Okay. Number of affected rows are 2, number of affected rows are 1 here. Okay. Total 2 rows are matched, out of which 1 is updated, 1 is inserted. Okay. Now you can see fifth record came, third record marked as a false. Now if you see history, so which is a merge, we applied the merge. When the merge applied, what happened? Let's see. when the merge is applied, I think 217b, this is a new file which is added. Okay, this is a new file is added, but we don't know what data is there in this file. Now let's understand through the transaction log. I think transaction log 8 is the maximum. Let's do one thing quickly, verify. If we go transaction log 7 is the last one. Let's go to commit info. Here you need to understand very carefully, observing. Okay, commit info, it is a merge. What it is saying, num source rows are 2, num out rows are 4. Okay, num target files removed is 1, num target files added is 2, num target rows added is 2, num target rows inserted is 1, num target rows matched updated is 1. One row is updated, one row is inserted. It is saying num target rows copied is, how many rows are copied is 2 rows are copied. It is saying okay, 2 rows are copied, one record is updated, and one more record is, so because if you remember, I have updated a third record, I have inserted a fifth record, meaning our first record, whatever is there, that is not having any change. So that's why this file is not changed. Now only change happened to this file 235, out of which 2 and 4 records are copied, and the third record is updated, and fifth record is inserted. Okay, number of target files are added is 2, number of target files are removed is 1. I think 2 target files are added. Let's see those things, what are those. Okay, now come here and see what is the file which got removed. 532 is the file which got removed. 532 is nothing but this is the file, it is saying it is removed. Okay, now let's understand what files are added. So this is the new file is added, we have not observed this. This is the one more Parquet files also added thing. Okay, see AC-C also available. I'll show you that in the data. This file also will be available. In this file, number records are 2 are added. That ID 2, maximum ID is 4, meaning 2 and 4. 2 and 4 are copy records, right, which are not having any change. That's why 2 and 4 is added into this file. And in the next file, number of records are 2. Minimum ID 3, maximum ID 5, meaning 3, 5 are added into this file. 3 and 5 is added into this file. That is 7b. You can see 217b. Understood, team, everybody? Now if you come here, so we observed only one data file. Now let me show you the other data file also should be there here. So 2 files we have seen added, right? 217b FAC. FAC. See, FAC is here, it is added, and 217b, this is the file. These two files are added. Okay, and these are the 2 records. It's okay. Now if you look at the data is spreaded across how many files? The total data, now if you describe history, you know it's a merge functionality, it will show. Okay, now my question to all of you, if I say select star from EMP, how many total files it is going to scan to get all the data?
3 5.
3 files. Okay, this is 1, 2, and this is a 3. Okay, let's see that. SQL/data frame. If you go here, you should see Number of files read is 3. Correct, team? Yes. If I say select star from EMP where ID in 3 and 5, how many files it is going to read?
1 file.
1.
One file it is going to read. Let's see that. Number of files it is reading is 2. Why number of files it is reading is 2? Three and 5, right? 3, 5 we have it in a single file. But number of files it read. We are seeing clearly, right? Number of records are 2, 3 and 5.
So minimum value 3 to maximum value 5 means 3, 4, 5 it will come, or only 3 and 5.
No, 3 and 5. See, 2 records means 3 and 5 only will be available, right? Okay. So let's see that why it is reading 2 files here. Let me read this. So first of all, 5 Shashi 33. Okay. 3 Sai 29. 3 Sai 29 age is there. 5 Shashi 33 age also is there. So these 2 records information is available here itself, but it is scanning 2 records. Okay, it's okay. I think it is simply reading. Let's see the other way. When we read 2 and 4, how many files it is reading? Let's understand. 2 and 4 also should, it is available even in a single file, but let's see, will it read a single file or 2 files? If it is reading 2 files means, okay, I think it is what is happening after this. Whenever we query these records or this record, I think it is scanning these 2 files. After scanning these 2 files, and it is bringing only like these 2 records. So this is basically, it has to read only this file, but it is scanning these 2 files. Okay, that is what we have observed. But this is Delta Lake basically smartly identify what file exactly it has to read, but here unnecessarily it is scanning 2 files. Okay, but we have seen it is not the case all the time, isn't it, team? Clear?
Yes, yeah.
Okay, now first let's understand checkpointing. So checkpointing means, I'll tell you, you can say underscore delta log. Yesterday we discussed the theoretically checkpointing. Now how many transactions happen total? 8 transactions, right? Now I'll add 3 more transactions. Okay, let's add 2 more transactions. If I added 2 more transactions, now let's see. Now you see, as of now you don't have any other files except 3 optimization files. All are CRC JSONs. If you have any doubt, you can see it. Okay, now I'll tell you what will happen. Now you see, so two times I iterated, 2 insert queries I executed. Now if you see, it's good. Still we have a CRC and a JSON. CRC and a JSON only available. Now very careful observe. Now I am doing one more insert. When I do a one more insert, now what happens, you see. Now you see, team. what will happen? What you are seeing here? What you are seeing here?
Checkpoint is there.
Find Parquet
For every 10
and
transactions,
transaction.
it is going to maintain a one checkpoint, so that instead of scanning these many transaction logs through the checkpoint, we know these 10 transaction logs available in the checkpoint Parquet file. So can we read this checkpoint file? Yes. You can't read it as a normal data. So you need to read it through the spark.read.parquet. Okay. You can able to read this Parquet file, and you can display it because it will give you the data frame. Oh, this is SQL notebook. And execute this.
To create the checkpoint, we have to enable any property, or automatically it will create the checkpoint.
No, checkpoint it will create, but what I'm saying is this check. Okay, so I'll talk about this checkpoint is creates automatically for every 10 transactions for now. Okay.
Okay. Mhm.
Now if you see, first you need to understand here. First thing is protocol. So what is the properties, table properties protocol is available. Second thing is metadata information it has stored. Third thing it has is two files are removed. After removing the two files within the this 10 transaction, it is summarizing the things. Okay, so two files are removed. Next five files are added. Okay, then one more file is removed, and after that again one more file is added. So these are the all the 11 rows we have. Okay, 11 rows information. This is what the information it is having in the checkpoint. The summary details it will keep it in this checkpoint Parquet file. Okay, now before I move on to the summary, let me tell you, if you look at the transactions that we have done is very small data, so unnecessarily it is creating lot of files for a very few records. So it is called a small file size issue. How to handle it we will see, but in the upcoming in the next next lab means not in the next session, immediately I'll be executing the next notebook, right? In the next notebook I'll show you when we apply optimizations, deletion vector when we enable, instead of deleting the existing file, adding a new file, it will mark the records as a deleted within the same file. And also when you enable deletion vector, it enables a compaction. Compaction means whenever it is creating a two small files like this, it will combine them into a single big file. It will not create a small files like this. That improvement that we can see now itself. Understood? Now checkpoint also not going to create very frequently, like when it is really thinks that it is really optimized. Now it's time to create a checkpoint, then only it will create checkpoint, otherwise it will not create checkpoint in the DBR version 15 and above, because here unnecessarily it is creating for small transactions. Okay, that thing we will see, but let me summarize. So first we added a table and I added constraints, then we updated the table, deleted the records, then we are applying the merge functionality like this. Clear, team? Any questions, let me know till here. So next we will move on to the another one. Clear? Okay, now let me tell you why I created this in the new notebook, new Databricks community account is now itself we are running out of time. If you see the cluster, I think cluster is shut down. Oh shit, whatever I thought of doing that is gone. This cluster takes generally 10 minutes. You see here, it is showing here in 1 minute. It's good. Do one thing. So maybe within the same account, let me do that. But let me delete this cluster because this cluster is not going to work for the deletion vector. For deletion vector, what you need to do, first let it finish deletion. Yeah, it is completely deleted. Click on create compute. Now you see I am creating a 15.2. Okay, dbr 15.2 I am creating. Click on create compute. Now I'll move on to the next notebook called Spark Transformation Part 12. So in this we will see with the deletion vector. Already anyhow the mount point is also created. We can see the other things. Before I start this notebook, I need to clean up the all the things, because here this particular property I am adding, delta dot enable deletion vector equal to true. Okay, but generally your admins, your Databricks admins, they will enable this enable deletion vector in the Databricks workspace level. Meaning whenever you create a table, you no need to mention this property, automatically deletion vector will be available to all the tables, applied to all the tables. Let's wait for a few minutes. Cluster will be available. This is the problem with this. So you need to spend at least 30 more minutes, team. It will be quicker now because we discuss, right? Most of the stuff will be same. It is easy for you to understand also. Today, just wait. Meantime, what we can do, we can go to Data Lake Storage. You can refresh it and you can see all the log files. Okay, checkpoint file, everything you can see. But we are accessing these things into the Databricks. There itself we are reading all this part. Now what I'm doing, I'm removing this India folder. I'm removing this India folder. Clear? Removed. Now storage is completely empty. Now I'll delete the tables that I created in the previous notebook using the latest runtime. I think you can also delete the tables. Let's wait until this cluster takes some time. That's why I created it in the other workspace. But it is 2 hours will be there idle for 1 or 2 hours. It is shut down in between. 3 minutes over. It takes 6-7 minutes. Let's see. Can you all confirm, are you all fine to stay for next 30 to 40 minutes, or you want me to take it on next session, or how it is? Is it fine? Can you all confirm, whoever is fine?
Yeah, I am fine.
Okay.
Everybody please confirm team. Sampath is fine. Anusha is fine. Others?
Yeah, fine.
Okay, thank you. Okay, now our cluster is also ready. Good. Because today is festival, right? That's why I don't want to force you.
What festival?
Kartik Purnami, something, right? You all will go to temples, right? Fine. Now I'll just go to this is anyhow, drop table EMP, because you remember in the previous notebook we created this table. That's why I am dropping this table. And I also need to drop underscore updates. I'll clean up. I'll just remove it after cleaning up. Few cleanups I need to do so that this will be fresh notebook. Okay. Okay. Drop table EMP. Drop table EMP underscore updates. Okay. Do and oh, I think along with the cluster, those are gone. Okay, fine. Now one thing will be still available. I think that is user slash hive slash warehouse. Here our this table will be available. That also we need to remove it. So now I want to, oh shit, 1 second. Just let me do all the cleanup step. It is good for us. Okay, see EMP updates are there that I want to clean up. Okay, because same things will be executing with the deletion vector. That's the reason. Okay, fine. I removed it. Mount point is already created. I am disabling this auto write and auto compact. Even though you did that, due to the deletion vector, some optimization will be done. I'll show you that. Okay. This path currently available or it is not available. Currently this path is available or not available,
Not
team?
available. Not
Not
available.
available.
Not
And
available.
one more thing is, you can, where we can see all the tables in the catalog, you can able to see all the tables. You see you don't have any tables. Good. Now I am creating a one table called EMP. Only difference is now I enable this table with the enable deletion vector equal to true. Okay. It will be little confusing. If you understood previous one, it is easy for you to understand this. Okay.
If you want to enable any properties while creating the table only, we have to
Here you
mention
can,
the table properties.
no, globally you can do. If
Mhm.
you globally, if it is disabled, if you want to enable for specific table, you can do this way. Okay.
Okay.
I'll show you that global versus local, how you can do in the next session. So this is the EMP table. Now you see as the table is created, underscore delta log is added. Now you can just see underscore delta log. It has the same two files, but optimization files, you see it is not creating now, because in the latest DVR those optimization files won't create. Okay. Some commit file will be created, but commit folder, if you see, it is just 0 bytes, meaning it's a empty, nothing is there. So just to say that this commit, it is committed as it is a successful transaction. So for first transaction, files are created. So there are two more transactions I am executing, as you know. Not null constraint, check constraint is adding. Now you can see describe EMP. These are the columns we have in the EMP table. Describe extended EMP. If you see, you can see external table. This is the location. And if you see here, this is basically the check constraint. See, check constraint is added here. Correct? Detailed EMP, you know, it will be displayed in a single row. Now you take this path and let's see, is there any part files? No, because we have not inserted any data. Underscore delta underscore log, if you see, there are three transaction files are created. Let's read the transaction files. There won't be any difference, because when you insert the data, then only there will be a difference. You see, this is a commit file where you have a create table. Next you have the metadata information. It has all this metadata and protocols are added. But if you see, when we enable the deletion vector, the min reader version and the min writer version for our Delta Lake tables are completely taken as a latest read version and the latest write version. Clear? Earlier whatever we have used is very basic. Now it is very advanced. Able to understand?
Yes.
Clear? Next.
Yes, yes.
Oh, we need to do few more, right? Okay. So let's open this. Just execute this. Commit info, if you see change column, you know this. When the column is changed, you can see uh, like nullable equal to false, it is added. And min reader version is 3, writer version is 7. It is not changed. But when we add it to 2, so that is nothing but a third transaction where we added a constraint. When we added a constraint, if you see here, so constraint is added here in the configurations, and you can able to see all the metadata and protocols. If you see min reader version, min writer version is not changing when you add the constraint, because earlier versions constraint was added in the next version of the write. That's why when you add a check constraint, write version is upgraded automatically. But now write version is all that constraints and all already available in this write version 7. So that's why it is not upgrading to new version. Clear? Are we good?
Yes.
Any questions?
Yes.
Okay. So CRC, we no need to discuss too much on the CRC. It has the same information, but JSON is our key. Okay, it is more of internal things for data integrity purpose. You can see here also metadata nullable equal to ID. Where is ID? Okay, this is, I'm reading the first transaction. That's when nullable equal to true. But if you read the latest transaction, metadata, if you see the check constraint, you can see here nullable equal to false, you can see here. So all the number of files is 0, because there is no files are added, metadata files. Now it's fine. Now describe history, same commands I'm executing till here, it's good, same as what we have learned in the previous. But now let's see, insert into EMP values are 1 rama 32 true. Okay, now one record I have inserted. Now you see insert also, I think it will be same. So one part file is added, delta log is added. So delta log, let's try to read and understand how to read the delta log, you know, right? So you can see delta log, if you read, commit info is write operation. Number of files added is 1, number of output rows is 1. So you are seeing same things. Added file is, this is the part file which got added. Number of records is 1 Rama 32, 1 Rama 32. It is very similar. Correct?
Yes.
Now, when you add this, which is a invalid insert record, when you add invalid insert record, it will fail, but still you know there will be a corrupted file. Okay, there is a corrupted file is added. Okay, here also carefully we need to take the added file. What is the file which got added? This is a file which got added with the, so this is the second execution, right? In this, so this is a file which has a 1 record. Okay, second file is the corrupted file. What is that corrupted file? This is 4. So this is the file which got corrupted. Okay, this is a file which got corrupted. Corrected him. It is corrupted. Now come down. Underscore delta log. You have seen there is no other delta logs are added. Okay, if you read the latest delta log, it has a 1 Rama 32 only. See, 1 Rama 32. To Krishna, regarding that, there is no new data is added. There is no new logs are added. You can see only one insert, 1 Rama insert only, right transaction is saved in the history. Now I am inserting a multiple records. You can see now one more new file is going to add it. What is that new file, team? 80A A4. 80A A4 is this is a new file which is added. But we can see through the transaction. This file is added, what data is added in this, correct? You can see, right? This is 87 which is added. Now I am trying to read the logs. So fourth log, let's try to read it and see what is there in this log. So commit info, it says it is just a write operation. Number of files added is 1, number of records added is 4. Type of operation is append operation. It is appending the data to the existing. Okay, so all these things are good. Okay, team. Now what happened? So this is the file cb87. You can see cb87 is added, and in this file you can see number of records are 4, minimum ID is 2, maximum ID is 5. What it means, team? 4 records means 2, 3, 4, 5 is added. Okay, now come here. CRC, I am just CRC is same, so no need to really see that. Okay, more of internal, leave it. Select star from EMP, and all these things when you query, you know how many files it is going to read in the backend. Correct, team? So when you read it, how many files it will read from the backend? Tell me.
2 files.
2 files that we have seen. Come down, job ID 51, 52, 53. This one. Number of files read is 2. Okay, so these things you know. Now I am updating the record. Very careful, observe. Okay, now I have to put here. Oh, I already kept it here. Here onwards, you need to be very carefully observe. So these are the 1, 2, 3, 4, 5 records spreaded across the 2 files. Now I am updating one of the file. Okay, so before update also, I also wanted to execute something and show you. Only write one record you inserted. When you insert the second record, it got failed. That is not tagged. You inserted a multiple records. That write operation is available. Now I am updating a record. Okay, when I update, very carefully observe, I updated the data. Okay, when I updated, now I am asking after update, what is the history? What happened? What happened, team?
Update optimization.
There are two transactions happened.
Yes.
There are two transactions happened automatically without notifying to you. There are two transactions. We executed update, but update and optimize. There are two operations happen. Now, when you query the data you will be able to see. Data will be good, but now you need to analyze the logs in the backend. See here, when you update something, it is just marking that deletion vector metadata is getting added. What happens is when you update or delete the data, so this is the file which has 1, 2, 3, 4. Now what happened? Let's say 4 you have updated. So when you update the 4, this will be marked as a deleted. Okay, and now 1, 2, 3 is copied here, and update record will come here. Now you have 1, 2, 3, 4 like this. Now it will optimize it, whether data is spreaded into multiple files. Can I put them into a single file? So that optimization is going to happen as a next transaction. Okay, just a minute, let me close the door. Okay, now let's understand. Only we have seen only these three files, but suddenly I'm seeing there are two more part files are added, one bin file is added. Now to understand all these things we need to go to the logs. If you see logs, 6 is nothing but a what, 5 is nothing but a what, can you guess it and tell me? 6 is a optimization transaction. 5th is the update transaction. First, let's understand update transaction. Let's understand update transaction. Okay, it's a update. Okay, it is a update. Fine. It will have number of deleted vectors added is one record is updated. I think number of added files is one file is updated. It is saying one file is added. It is saying in the commit info it is a update operation. As it is successful commit info is there, one file is removed, team. What is that file? This is the file cb87. Cb87, what is cb87? This is the file which got removed. Okay, so this is the file which got removed, which has a number records are 4, minimum id is 2, maximum id is 5. This file got removed. But let's immediately what is happening here, it is saying it is added a new file. This is the file. What happened? Just it is added a this file. In this file, what is there in this file? Can you see? It is saying number of records. So one record is there. That is a 5 new Venkat 55. Meaning the updated record. Okay, the updated record 5 is there. One record, that is 5th updated record is there. Correct? In this newly added file, 5th record, that is one record is there. You can say number records are 1, that minimum value is also this, maximum value also is this. Now come here, and if you see what is this file, team, looks like this is the file which is existing. I feel like this is existing file. You see here, is it matching with this or not? Meaning like first it said delete this, but deletion vector said, hey, just wait, don't delete this file. let me update. Okay, you can see deletion vector is added here, and it said cardinality is one record you have to mark it as a delete. Okay, so you can see number of records. Now it has this 4. What are those? 2, 3, 4, 5. All the 5 records we have, sorry, all the 4 records we have minimum 2, maximum 5, but it is marking one record as a delete. That's why deletion vector it is added. Cardinality is 1, meaning 1 means one record it is updating, meaning same data will be available. This file will be there. Only thing is 5th record mark as deleted. Understood, Tim? Yes, this 5th record is delete, like updated, it is marked as a deleted. Now, okay, let's see. Understood this one? Now this is how the things what we have currently when you analyze the 5th transaction. Now it is applied a next. What happened? It applied optimization. So now that optimization what it has done, we need to see in the transaction log 6. Commit info. So the optimizer executed. So optimizer added a one file, removed a 3 files. Okay, optimizer added one file, removed 3 files. What are the 3 files removed? Let's see. First one is A4. A4 means this is removed. Okay, next number of records is 1 is there, it is removed. Next number of records 1 is there, that is 7440. This one, this is also removed. Number of records 4 are there. What is cardinality? Deletion vector is also there. So what is this file? cb87. This file also removed. Correct? Correct. Now after removing all these 3 files, now it is added a next file called this. What is this? This is a new file is added. It is added a new file. So in this file what it is doing, you see here. It is just said number of records is 5, minimum ID is 1, maximum ID is 5. Okay, so meaning latest all active data, all 5 records, it put it into a single file, that is nothing but this. In this now you have 1, 2, 3, 4, 5. This is called a compaction. The optimizer identified unnecessarily data is spread across multiple files. Let me remove all these part files. Let me keep single file. So because let's imagine these files are now, let's say this data is updated 7 days back. Now what happens? 7 days back means these all are old files. Permanently it will get deleted. Only you will have a single file. It will be more of a cleanup. Okay, and it is easy for us to read the data from a single file instead of scanning through multiple files for optimization. Are you able to see the clear picture from the backend what is happening or not? Are you able to see clear picture what is happening in the backend or not? So CRC I'm not
Yes.
like, you can see if you want, but you can analyze. Okay, so nothing will be there, it is more of internal things. Okay, now same thing applies when you apply. Okay, when you do a, okay, now when I query this, let's understand how many files it is really scanning. Correct?
One file.
But as per our understanding, sorry, it is wrong. As per our understanding, it has to scan only one file. Let's see, this is job ID 92, this one. As per our understanding, it has to read only one file. See, number of files read is only one. Now it is reading only one file. Understood, Tim? Now you can query. If you say where age equal to 55, nothing will come because, oh sorry, age 55, I think one record is there, it is giving. But all these 5 records are now available in a single file or not? Yes.
Yes.
Everything is available in a single file. Okay, clear? Till here clear? Now delete from emp where name equal to new Venkat. Now it is optimized. It is now we are deleting this file. Okay, now let's see what will happen. But anyhow, there are a lot of part files now. You no longer you can able to understand. There are 5 Parquet files. Here also 5 are there, meaning there is no new Parquet file is added. But before I move on to the further, after deletion team, immediately can you see describe history this table. See here, after deletion there is no optimization is required because it's very simple. It has to add one cardinality within the same file. So that's why it is not executing any optimization after deletion. Now it is analyze deletion vector. Is it really I need to go and run some kind of optimizer? If it is really required, it will do, otherwise it will not. Okay. Now 7th transaction, let's try to analyze. Let's go to focus mode. So you can see it's a deletion. Number of deleted rows are 1. Okay. Number of deletion vectors are added is 1. Now which file is removed, Tim? Which file is removed? 483E. 483E. So this file is removed. Don't think that it is removed. It is removing, but deletion vector said, hey, just wait. Let me tell you what you need to do. Don't delete that file. So keep the same file. You can see 483E. Just keep same 5 records. Mark one record. See, deletion vector is added. Mark one record as a deleted. Cardinality 1. Understood, Tim? That's how it is going to mark it. But it is not really going to delete any data. Clear, Tim?
Yes.
Same merge functionality we have seen just now. You can read the read the target data 1 2 3 4 only you have. Third record I am marking it as a false. Fifth record I am inserting. Now you can see 3 5. 3 is updated, 5 is the new record. Here you have 1 2 3 4 records. I am running this merge functionality. After running merge functionality, I want to see is there any optimizer is running in the backend. So that's why describe history of EMP. Okay, no optimizer ran after the merge also. Now you can just see, okay, 1 2 3 is updated, 5th is inserted. Now we can see is there any new Parquet files are added. How many Parquet files we have? 5. Now see 5 only are there or more are there. See 7 are there. Okay, 7 are there. Let's try to analyze the logs. Let's analyze the logs. Okay, so bin is nothing but a deletion vector, that metadata, which records is removed that information. But we want delta underscore log. Okay, now just execute this 009.json. Now if you come here, so you can see commit info, it's success transaction. Oh, but why it is? But why it was not showing in the history? Okay. So optimizer ran after merge theme. You can say optimizer ran after merge. But now if we analyze very similar to the previous, eighth one is the merge team. Eighth one is the merge. So very quickly I'll tell you, try to understand. So it's a merge commit, you know, commit is merge. Removed files. What is the files removed? You can see this is a 483. This is what is marked for the deletion. But is it really deleted or not? We can able to know only when we see here. When we see the data here. So this is a new file is definitely added with the 2 records, 3 and 5. Update record and new record is inserted into this file. 3 and 5 is available here. 3 and 5 is added here. And then within the same file, see F483. So in the same file, 5 records are there, but cardinality is 2. It just marked 2 records as changed. So that is, I think, fifth record already marked as a deleted earlier. Now third record also marked for deletion. That's why here you have a now 1, 2, 4 only active, and 3 and 5 2 are marked for the deletion. Okay, that's it there. Now let's analyze the optimizer. What optimizer done we need to understand. Now if you see, this is optimizer operation. Optimizer removed 2 files. Looks like, what are the 2 files? 483e, this file is removed, and I think second file is 9c6, this file also removed. And what is added, let's understand that. It is added a 43. This file, is it existing file or new file? Let's see. I think it's completely new file. In this file, what it does, you can say number of records are 5. 1 is the minimum, 5 is the maximum, meaning 1, 2, 3, 4, 5. So 3, 5 from here, 1, 2, 4 from here. These 2 files merged into a single large file. Understood, everybody? You have seen, right, deletion vector, how it is behaving.
Yes, Master.
Yes.
So describe history, you can see that here. Okay, so checkpointing one, let me show you. Yeah, first you see underscore delta underscore log. Okay, so this is not running, any checkpoint is not there, up to 9 is ran. Now I'll do a 20 more, oh shit, 1 second, 10 more inserts I am doing into the same table, meaning 10 more transactions I am inserting. Ten transactions, right? It's just inserting one after the another. 17 version, 18 version, 19 version. Describe history. EMP, you can run it and see how many write operations are executed. You can see here so many writes. See, now after optimize, there are a lot of writes happened. But now if you see underscore delta underscore log, it will not have any such checkpoint. It will not create checkpoint just like that. It is when it is really optimized, that time it is going to create. Are you seeing any checkpoint kind of thing here? No. Clear? So deletion vectors like delete, update, and merge operations, when you apply, you have seen optimizer is running, right? So now to enable that, so let me explain to you 2 more use cases. Create database delta DB and use database delta DB. So now I'm dropping the cust table if it is available. Deletion vector I'm enabling for the cust table. So this cust table is not available as of now. So we are creating first time. We are as of now working with the employee table. Cust table is not there. Now I am inserting a 1 record. Okay, now you see part file is there. Yes. Delta log is there. Yes. Now let's read the delta log and see. Okay, commit info is basically write. Yes, you know this part file is added, it is inserted, the num records is 1, id is 1, value, so everything is fine. Now I am deleting that one record, whatever is inserted, same record I am deleting. Now what happens, you see one bin file is added, metadata file. So under delta log, one new log file is added. In this log file, if you see, it is not adding or it is not rewriting something like that. It is simply, okay, removing this file, because no longer this file is required, isn't it? Because this file contains a one record, that one record also now removed, then this file can be removed, no need to mark it as a deleted or something like that. So that is based on use case, whether it has to mark that particular record as a deleted or file itself can be removed. Now this file is having one record, now as I deleted that one record, this file itself removing. Understood? This is a use case one. Everybody understood? Now use case 2, if you see, drop table if exist, product table I am creating with the deletion vector. I am inserting a product A, product B, product C. Now you can see logs, files will be there here, data file is there. Now delta log you will have. So you know when you insert it, definitely you will have the stats, right? It maintains the stats. So write operation, files added is 1 with the 3 records. Okay, what is that file? That file name you will have here. Now delete the one record out of those many records. Okay, now when you delete only one record, what happens? Will it rewrite into some other file?
No.
No, within the same file,
Delete that.
it is going to mark it as a deletion. You can see here. So this is a commit file where you said optimize. Oh, it is optimizer is running. What optimizer is doing? It is just saying within the same file 3 records are there. Remove this file. But immediately it said, hey, don't remove this. Simply keep that file. Number of records are 2. Okay. One record is basically. But why I am seeing only one part file here? Okay, now 2 part files come. I think optimizer is running. By that time we are started checking. Okay. So if you see logs, right, this is the optimizer log. If you see this is a deletion log. What deletion log says is, you can say commit is a delete. What delete does, it just said number of records are 3. Okay, this is a part file which is there, which we want to remove it. But here what is happening here? What is happening here? It is basically said cardinality is 1, and within the same file 3 records only we are keeping. But later optimizer ran and it executed, it removed those that file, and it added active 2 records into this file. You can see number records are 2 in the new part file. This is 7f. The removed file is different. It is a removed file is 1ca. And commit, if you see, this is optimizer. Describe history product, if you see, it has a delete and the optimizer app. Okay, yeah, that's all for today, team. So tomorrow we will see the, not tomorrow, next session will be on Monday, so we will see the remaining optimizations. Please practice these things. Okay, any questions? Anybody have any questions? Confirm, team, quickly, any questions?
No, no.
Okay, no questions. Thank you.